Hello. So, we are into the second lecture of first week on water economics and governance. We will continue our discussions from where we ended in the previous session. Previous lecture we have basically talking about the global perspective of water resources. So, we did discuss that what is the net estimated or predicted amount of the water that is available into various phases including ocean, atmosphere, river, streams, groundwater. So, in all these different phases, what is the estimated total volume of water present in on the earth. The time that water spends into these medium varies from a few days, as in case of atmosphere it is approx estimated time, average time is around 9 days, to tens of thousands of year or even longer when it goes in the form of ice caps and glacier. This is what we are talking about earlier. Continuing from there on, the if we see the earth's surface water is found in liquid, solid or gaseous form. When it is in the atmosphere, it is in the gaseous form. When it is typically in the oceans or groundwater or lake, rivers, it is in the liquid form. However, it could be in the solid form when it is in the form of ice caps or glaciers. We also observed that this residence time varies from a few days to thousands of years, as we were just talking about. The important point or one of the main concern for civilization is that the amount of water, amount of fresh water that is available, as if you just move back to the previous slide, you will realize that if you account for all these, so you see that the fresh water over here is actually, if you see total water into the river and lakes and even including the groundwaters for which generally people compete, is very less. So, since the fresh water availability is that low, so all of us, all people around us are actually competing for that water which is actually less than 1% of the total water. So, this is what for not only human beings, but human, animal, plants, ecosystem, all of us are competing for this water, fresh water, which is actually less than 1% of the total water. Typically, if we put our emphasis onto human beings, one person needs minimum of 20 to 50 liters of safe fresh water in a day for its drinking, cooking and cleaning purposes. That is what the various estimates provided by the WHO or UNICEF suggest. So, each person needs around 20 to 50 liters of safe water. Now, if we see the total availability of fresh water and its distribution, of course, which we will just talk about. So, what is seen or what is estimated or predicted by the larger organizations like WHO or UNICEF working in the region. So, they estimate that around 3 in 10 people worldwide, which is approximately 2.1 billion people. This is a very latest report. This was just published in 2017. Okay, you can see the source over there. So, nearly 3 in 10 people worldwide, overall estimating around 2.1 billion people on the 2.1 billion people you see here, they lacks access of safe and readily available water at home. So, there is not adequate amount of water to feed in these many number of people, and 3 in 10 is a large number. Around 30% of the worldwide population is sort of declined to give access to the safe and adequate amount of water and in their homes. The situation is actually even worse for sanitation. Although this course primarily targets water, but sanitation is another associated thing which with water, and if you see the case of sanitation, it is even worse, as around 6 in 10 people, which goes to around 4.5 billion people in the world. Around 60% people in the world does not have safely managed sanitation. So, that is the sort of scale of the issues which is very alarming. Okay. The around 30% people do not have access to the safe water, and around 60% people, double of that, do not have the access to safely managed sanitation. So, that is sort of the very high point of concern. Now, if you see the global criteria or international norms, when the per capita availability in a region or zone or a continent or a country, let us talk about a country. So, when this per capita availability in a country is less than 1700 meter cube per year, meter cube of water per year, the country or the zone or the continent is referred as water stressed. While if it falls down below 1000 meter cube per year, then the per capita availability comes below 1000 meter cube per year, then we call that as a water scarce country. So, that is how basically the terms are allotted. Many of the African countries, we keep on saying that they are water stressed country, water scarce country, and all these terms. So, this is what these terminologies means. Okay. When the per capita availability is less than 1700 meter cube, it is a water stressed zone, while if it dips below 1000 meter cube per year, it is a water scarce zone. Now, if you see the global water distribution, how this water is distributed, it's sort of you see that even the natural distribution of water is not very judicious. If you see the growth of civilization, as per the growth of civilization or as per the habitat areas, you see that the global water distribution. So, there are countries, if you see this whole lot of European belt over here, you see they have plenty of water, there is little or no water scarcity. Okay. Large part of US is more or less do not have too much of water crisis or water issues. Okay. Although there are some states over there which you can see, the southern part also you can see over here that there are issues related to water, which leads to physical water scarcity mostly, okay, or approaching physical water scarcity, as you see in many of the Asian countries over here. Okay. There are economic water scarcity as well. If you see, the large part of your Africa is under the economic water scarcity. Okay. Similarly, in India, conditions are not very bright. Okay. In our own country, if you see, so you see that most of the Indian territory are either under physical water scarcity, economic water scarcity, or approaching towards physical water scarcity, the central part, that some of the central region that you can see of. So, that is how the water is sort of distributed, the natural distribution of water across the different continents, different countries, as you can make it out from here. There has been several studies estimating uh, the water availability or scarcity in future as well. So, quite a few of such information is available. One such information is presented here, which you can see on your screens, which is from study by Ernest and Young done in 2011. So, they figured out that apart from, of course, few African countries where there is a stream water scarcity, as you can see it here, India and China are kind of the largest countries which are which are actually under water stress now, and the problem is not looking brighter in future as well, if you see. So, in around 2050 also you see, and even though now, although there is a debate, because if you see the per capita water availability at the time, the different agencies have report different numbers. We are actually doing at around 1800 or so. So, that way terming us as a water stress by international norms is a little tricky business. However, yes, we are in that range, and by 2050 we will certainly, most part of India or barring a few actually, will be under significant water stress. Okay. This which is actually leading to, as was discussed earlier also, that due to the increasing demand as well as increasing demand arising from the population growth as well as the developmental activities. So, demand is increasing, resources are same, there are no like new resources coming up from for fresh water. So, with the same resources, if demand is increasing, population is increasing, so obviously per capita availability is likely to fall, and that is what is reflected in these studies that predict India to be water stressed very soon, or even some already have declared it. Now, if you see that from where this water comes and where it goes, of course, we did had a look at water cycle involving different processes, how water changes phases from one to another. So, keeping those in count, the budgeting of water is done either for a continent or for a nation or for a even for a simple small watershed. So, if we consider this entire globe as a watershed, okay, and try to get the global water budget, what we see that the inflow is actually in the form of precipitation mostly. That so, typical water budget equation or any budget equation for that matter will be as you see here, that flow coming in minus flow going out would be equal to the change in the storage. So, in terms of water, if you see that if you consider our surface, let us say, as a boundary, so that way flow coming in may be in the form of precipitation. So, that is estimated to be 834 millimeters. Now, this unit millimeter means the as we predict the rainfall and all these thing in mm and that way. So, it has to be sort of multiplied to the overall global surface area in order to get the total volume of the precipitation. So, as was sort of estimated in the earlier slides that you saw, of which the large portion goes to evapotranspiration, some goes to the some is discharged to the O1 oceans. The discharge to the oceans from surface runoff is around 204, discharge to oceans from base flow is around 90. So, this gives you the total discharge to oceans of around 294. The 630 millimeter of water actually goes to infiltration. So, that is how this this water budget suggests that these are the routes of water flow. Now, if you look at the water budget equation, the basic, very basic universal water budget equation for any water set can be expressed in the terms of equation that you are seeing on your screen over here. So, P plus Q in, where P is your precipitation and Q is the discharge of water that flows into the watershed. Now, in case of when we basically sort of fix a watershed, there might be some inflow other than precipitation as well. Okay. Some river might be coming into that watershed, so that those sort of flows are inflows to the watershed. So, the precipitation is one inflow which could be in the form of either the precipitation here is not limited to just rainfall, it includes rainfall as well as snow and other form of water which comes into the watershed from atmospheric routes. So, that is your precipitation, and then Q in is the surface water flow into the watershed, that is the total water coming into the watershed. Now, if you see that the basic equation inflow minus outflow is going to equal to the storage. So, your inflow will totally be equal to the outflow plus change in the storage, or that way. Outflow primarily is in the form of evapotranspiration ET, that you are seeing this term over here. Now, this ET includes, or evapotranspiration includes both evaporation from the water bodies or either surface water bodies or whatsoever water bodies particularly in the region, while transpiration or other surfaces, while transpiration from the plant or green surfaces, that way what we call. So, evaporation is the entire water escaping to the atmosphere either through evaporation or transpiration. So, that is one way of out from the watershed, which is your ET. The another Q out is water outflow from the watershed, any river, canal, channel which is taking water away from the watershed is your Q out. Then you see the other term which is change in the water storage is in the watershed. Now, water storage changes do occur at surface level as well as subsurface level. So, one can split this term into the infiltration plus change in the surface water storage, because change in storage, as I told you, that will have surface component as well as subsurface component. Now, this subsurface component could further be because when the water infiltrates through infiltration, it is not necessarily that all the water will reach to the aquifer and all that. Some may be basically get stored as a soil moisture in the subsurface. So, that is also a form of water which is or change in storage water. So, earlier your soil moisture could be low, while after precipitation when the water infiltrates, water goes through, your soil moisture levels may be high. Those kind of storage in the soil moisture, storage in the surface water bodies, what you see, the increased level of water in the lakes, ponds, increased flow in the river, at any given point of time. So, all those changes in the surface water storage plus changes in the groundwater storage plus changes in the soil moisture or other form. So, collectively that term is mentioned here in the delta S, which is change in the water storage within the watershed. So, that is what is your typical water budget equation, which is used for any watershed, and that way we can have an idea that how much water is coming in, from which forms it is coming in, and how much water is leaving the watershed and in what forms. Based on similar exercises, a gross estimate has been developed. It was published in World's Freshwater Resources in a chapter in a book edited by Galrick, which is titled as Water in Crisis. So, they estimated that the different forms, or they estimated the quantities of precipitation, evaporation and runoff for different continentals. So, as you see, this is sort of very interesting info. The South America particularly is sort of the richest continent in terms of water inflow. Okay. So, you see that around 16,000 meter 1600 millimeter per year, or if you see in the total quantity, it is close to 28 more than in fact 28,000 kilometer cube of water coming in through precipitation. While of course, when the precipitation is high, you will see the higher losses in form of evaporation and runoff. The Asian countries also have significant amount of water coming in form of precipitation, but if you see, because that is primarily because they have a large area. So, the over 32 kilometer cube of water that is coming is actually coming from an average annual precipitation of 740 per mm. Okay. So, this large number is not because of large inflow, but because of large area. So, that is what is the total water coming in, and this corresponding total evaporation is of the order of 18,000 kilometer cube, while runoff is of the order of 14,000 kilometer cube. So, that is what are the number for Asia. The conditions, if you see, are bearing South America, which is very rich. The average precipitation, if you see, is more or less in the similar ranges across Australia, Africa, Asia, even Europe and northern part of America. Still we see that if we go in detail into these specific continents, like if you see the details of water storage in or water coming in Africa, you will see that the southern part of Africa, in and around South Africa, there is adequate amount of water relatively, while if you move up, you see that the most of those countries are under water scarcity. So, that's if we go into the more fine details, if we go into the deeper into the specific continents, but otherwise as per the estimates, if we go by these numbers, the average annual precipitation more or less in the similar range, a little plus minus over here and there, except South America, which is having very high precipitation. So, with these Yeah. Now, if you see the total land and water resources globally, which is sort of this information is given in our Central Water Commission website. So, total water resources globally, if you see, it's the again if you go by the volume, around 1400 billion cubic meter lies in the form of salt water, which is in the oceans, while 37.5 million BCM lies in the form of fresh water. The sources of fresh water, if you see again the different estimates, the estimates are this is the all the information available at the CWC website, but the information that is presented is more or less same that one we saw from the USGS, US Geological Survey. So, let us move ahead, and what we see that how the water is getting used, because so far we have been talking about the availability. Now, let us talk about how this water is being used on a global scale first. So, the World Bank annual report suggests that globally around 70% of water goes for agriculture sector. So, that you can see here that 70% of water goes under agriculture sector. The next largest is industrial sector, accounting for around 22% total consumption of water, while the domestic sector, or what we can call it urban sector, consumes around 8% of the total fresh water. So, that is World Bank as per World Bank annual report. While if we go into the sort of, if we bifurcate these uses in terms of underdeveloped or developing countries and developed countries. So, there is an interesting shift of water use pattern which can be observed. The low and medium income countries, typically, which we call that underdeveloped countries or developing countries, the large portion of water, because in these countries the major source of income and major source of habitation is agriculture. Obviously, the large sector goes to the agriculture, which accounts for around 82% of the total water consumption. This is as per the United Nations World Water Development Report 2. 10% goes to the industrial and 8% goes to the domestic sector, or what we call urban sector, urban or rural, whatever. 8% goes to the domestic sector. Now, if we shift focus to high income countries or developed countries, you see that in this is grossly known by one and all that there is more of industrial activities in developed world as compared to the agriculture, and that is seen in the water consumption as well. The water consumption is in the industrial sector in the developed world or high income countries is of the order of 60%, a remarkable shift from 10% in the low and medium income countries to of the order of 60%. The estimated number is 59% though. So, so around 59% in high income countries. This shift is again because of the high industrial growth. You see the agricultural, on the other hand, agricultural sector, which consumes around over 80% in the low and medium income countries, the consumption in agricultural sector in high income countries is around 30%, of the order of 30%. So, the major consumer there becomes industrial sector, whereas agricultural sector takes the second place. The consumption in the domestic sector in the developed countries is estimated to be around 11%. So, that is how this uses of water or consumption of water or demand of water from different sector to sector changes when we look the country to country that way. So, we will end this lecture over here and discuss the remaining sections in subsequent lectures. Thank you.